We've been sent a message from Dr. Kenji Emerson, and the message tells us we've put together this data table for you. It has data about the amount of rain from Galetown's recent rainstorms. It also includes information about the amount of surface water in Galetown. Remember, local surface water is all of the water that is at the surface and that can evaporate, including water from the lake. So we have our 4 different storms recorded, and we can see storm 1, this is before the lake, had very little surface water, mild rain. Storm 2, now the lake's been put in, has high surface water, moderate rain. Storm 3, again after the lake, high amount of surface water, now that we have that lake there, and severe rain. Finally, storm 4, again after the lake, has high surface water and very severe rain. Wow, look at those numbers. Originally, before the lake, the rain was about 6 centimeters of rain. So that's about little less than 2.5 inches. After the lake, they were getting 12 inches. That's a foot of rain with one storm. That is a lot of water. Wow. We're going to come back to this. This is very interesting evidence. We're going to be thinking about these 3 claims and continue to go back to these during the unit. Just out of curiosity, I wonder if any of these claims are standing out to you right now. Let's just spend a few minutes remembering and going through the water cycle, because it's going to help us with our activity today and help us understand those storms that we just saw at the beginning of this video. So the beginning kind of, or it's hard to say beginning, but we're going to start just thinking about surface water and how that's any water that's on the ground, lakes, puddles, ocean, anything like that. So if we're thinking Galetown, even before the lake, there was surface water on Galetown, but once that lake was put in, the surface water really increased. Now, again, there's water all over this image, but the most notable part is that surface water in that corner. Now, we can also see in this image, we have that yellow arrow, which is just showing us that energy from the sun is going into the water. When energy from the sun is going into the water, we start to get that surface water evaporating. That's known as water vapor. So water that is evaporating is now creating a gas form of water known as water vapor. As this happens, now we start to get this very warm air parcel. And remember, an air parcel is just a section of air. In that air, we'll have evaporated water. We'll have water vapor. So when the air parcel is warmer than the surrounding air, that's what's happening here. You can see the inside of the air parcel is warm. The outside of the air parcel is cold. So the surrounding air temperature is cold. When this happens, energy is going to move from the warm air parcel to the cold outside air. So energy always moves from warm to cold. So we're going to get that energy leaving the air parcel. As energy leaves the air parcel, this is going to cause the air parcel to cool down, and any water vapor, any of that gas water that was inside, is now going to start to condense, meaning start to come back together, start to form bigger water droplets, which is condensed liquid water. Eventually, this will form a cloud and it will fall as rain. So we kind of saw this idea happen with our experiment that we did 2 days ago, where we saw that if we blew warm air into a bag and we put it in the cold freezer, we saw condensation. Whereas if we put warm air, and remember, in that warm air, there's a little bit of water vapor. If we blew warm air into a bag and left it in a warm room, there was no condensation. So when we looked at this image, because we had a warm air parcel and cold surrounding air, we got condensation, meaning we're going to get this condensed liquid water. We're going to get a cloud. That's what a cloud basically is. It's lots of little water droplets starting to come together, forming condensed liquid water, bigger water droplets, till eventually we get rain. So going back to that image we saw before, we're going to focus on storm 1 and storm 2 today. We're going to be creating two models for these two storms. We're going to create a model from before the lake was created, storm 1, and a model from after the lake was created. This is going to show us and help us see if the lake is affecting the amount of rain in Galetown. It's going to really let us see if that is a factor and if that's making a difference. So you're going to be seeing an image, a doc in a few minutes that looks like this. We're going to together be modeling storm 1. So again, in storm 1, there was low surface water and a mild amount of rain. So what we're going to be doing when we get to storm 1, you guys will be doing storm 2 in a few minutes. We're going to start with the first direction here. And it tells us to select a water vapor card for inside each air parcel. So since I'm doing storm 1, I need to think about what was the water vapor like in the air before storm 1 happened. So if I think about this, I know before storm 1, we found out that there was no lake. There was very little surface water, and I could see that in my image. Meaning, if there's not a lot of surface water, we know that there's probably not a lot of water vapor. So I can already, for before, select the low water vapor card. I also need to select a water vapor card for after storm 1. So since I didn't have a lot of water vapor to begin with, I'm still going to continue having low water vapor afterwards. So I've now dragged the low water vapor card for before, because again, there was very little surface water. And after the storm, it's going to continue having very little water vapor. There's always a little bit of water in the air, but it definitely would not be high. Next, I'm going to focus on selecting a temperature card for inside the air parcel. So I need to think about first, before the storm, what was the temperature like inside the air parcel? So at this point, I'm thinking about the idea that since water was evaporating up from the sun's energy, water was evaporating, turning into water vapor, it was somewhat warm. So I would say that I have a high temperature at this point inside the air parcel before the storm. So this is when that evaporation was really happening. After the storm, now energy has been leaving, and that's why I have these red arrows here. Energy has been leaving the air parcel, causing the air parcel to cool down. So at this point, after the storm, I would say that there's a low temperature. Finally, we have to think about the temperature card for the surrounding air outside the air parcel. So again, I'm thinking about that Ziploc bag experiment we did. If we're thinking about the outside air, we know that since there was a storm, condensation had to happen. For condensation to happen, we need to have a warm air parcel and a cold surrounding air temperature, which means I'm going to be dragging on that low temperature card. And I dragged that on for before because the temperature was cold. And for after, it still remains a pretty cold air temperature. Last thing I need to work on is 4, which says select a cloud to show after the energy transfer. So after the energy transferred, because energy left the air parcel, the temperature cooled down, which caused the water vapor inside that air parcel to start to condense, which means we are getting that condensed liquid water, basically creating a small little cloud, which means we will have a little bit of rain. And that makes sense with what the evidence that we had seen. Now, your job is to model storm 2. I just modeled storm 1, which may be a good reference for you to go back to. If there's any parts you're having trouble with, you're going to follow those 4 directions: step 1, step 2, step 3, and step 4. You're going to follow the same way I did storm 2, but you need to think about now we have more surface water. So you're not going to have the exact same answers as I did in storm 1. You may want to change a few things. Think about this one. See how you do. When you're finished, you may want to think about these claims again and really think about what you have seen. Reflect on what you've learned so far and see if you agree at this point with any of these three claims.